Hello, I'm Issa Mazoud. I'm technical sales at DecisionBrain, and today I will make a demo of a supply chain planning application. First, I will say a couple of words about DecisionBrain. Then I will tell you about the sales and operations planning process, why it is important, and some critical aspects to consider. And finally, I will demo a supply chain planning application. So, at DecisionBrain, we are specialized in implementing and deploying decision support solutions to optimize industrial operations. We use optimization and AI to optimize manufacturing operations, logistics operations, etc. I will tell you more about this in the next slide. We have 400 plus combined years of experience in advanced analytics. This includes AI, machine learning, mathematical optimization. Our main offices are in France, in Paris and Montpellier, but we also have offices in Hong Kong, USA, and Italy. So we deliver solutions in two main domains. The first domain is workforce and maintenance. This includes workforce planning and scheduling, considering aspects like upskilling, hiring, and how to generate the best workers plan to maximize the service level and reduce the costs. In this first category, we also provide maintenance optimization solutions, considering aspects like equipment usage forecast, planning and scheduling the maintenance operations to minimize downtime, maximize the availability of the equipment, and minimize the maintenance costs. The second domain is supply chain, and this is the focus of today's presentation. In this domain, we focus on supply chain operations, including manufacturing, logistics. We offer solutions at the strategic, tactical, and operational levels, like network design, production planning and scheduling, sales and operations planning, transportation optimization, etc. So, what is S&OP? So S&OP stands for Sales and Operations Planning, and it is the process that allows companies to align the demand with the supply. In other words, how do I plan my operations in the best way to respond to the demand? When I speak about best way, this implies that there is an evaluation of the quality of the plan, and this depends on the company. Some will focus more on maximizing the revenue, maximizing the service level, reducing inventory and processing costs, or some combination of different criteria. And this is where optimization technology and AI is very powerful. So the first prerequisite to plan the supply is to understand the demand. So what will be the future demand? So for that, we need to clarify the company strategy in terms of customers, in terms of markets and products. For example, we need to consider new products introductions or products that are discontinued. Then we need to forecast the demand for the planning horizon. So this process requires a collaborative work from different departments, from marketing, from sales, from operations, from management. And naturally, we need to reach a consensus forecast that will be the basis for our supply planning. So once we have a clear idea and a clear vision about the demand, we need to plan the supply accordingly to avoid stockouts and overstocks. So this includes the production, meaning what to produce, where do we need to produce and when. But also we need to consider other aspects like transportation between warehouses and procurement orders. So now to have a realistic plan, we need to consider the operational constraints like the production, the storage capacities. In some situations, we even need to consider the suppliers' capacities when they represent a potential bottleneck, and other operational constraints like minimum lot size, etc. So to summarize, in order to do the supply plan, we need two main information. So first, we need the demand, and also we need the operational constraints. Why am I specifically mentioning the main inputs? Because these are the inputs that are impacted by disruption in demand, disruptions in machines availability, in suppliers, etc. And this is very important to take into consideration, especially when planning the supply chain for a medium to long term. Here in the S&OP, we consider a time horizon of 12 to 24 months. And what is crucial here is to be able to do scenario planning and compare different scenarios to be able to take more robust decisions. Typically, we present a worst case, a best case, and a most likely scenarios to take strategic decisions like a resource allocation, capacity investments, etc. So to have a clear vision of the future demand, we need to do forecasting. So we need to plan demand, which is the collaborative process that I described earlier that allows to reach the consensus forecast. In this demo, I will be focusing on the supply planning or supply chain planning, which is done over a horizon of 12 to 24 months. In terms of scope, the supply chain planning needs to consider the complete supply chain from the suppliers to the distribution. And here I'm speaking, of course, about the general case. In some situations, the suppliers are not necessarily bottlenecks, so we don't need to consider them. Usually, we plan at the product family level, but when relevant, we may go into the SKU level. This process is an iterative process. It is run monthly. So one important aspect is to keep monitoring the S&OP and the adherence between the planned and the executed. This allows to improve the process over time and reduce the gap, which at the end allows to take more informed decisions and make more realistic simulations. So once we have the supply chain plan, we can move to the finalization steps, which include the business integration, meaning dollarizing the plan and do the financial projections, review the gaps, and when necessary, make an action plan. And then we have the executive review, in which we highlight the most important aspects of the plan, we highlight the projections, and this is where we get also the green light and take the business decisions. So now, just before showing you the demo, I just share, without going into the technical details, there is an optimization model that is at the heart of the decision process or the planning process. This model represents the supply chain. And what is important here is to have the right model with the right balance between performance and precision. So we don't want a model that is over precise for the decision that we are making, because having a more precise model will lead to a less performant model. So we really need to get the right precision there. The optimization model itself takes input data. So it takes data about demands and priorities will allow to make the compromises when there is not enough capacity, for example. We need information about resources. We need information about the calendars and availability of these resources. We need to know what are the inventory levels of finished products, of semi-finished products, and raw materials as well. If there are materials that are procured, we need to know the informations of that. Of course, we need to know the recipes, so the production processes, the different costs and yields of these recipes. We need to know the supplier's capacity and lead times in case that those suppliers are bottleneck. And of course, we need to know all the other operational constraints that we need to consider in our models, like minimum lot size, like a changeover, etc. So all those input data are considered with one or more optimization models. And this is really the heart of the application that will generate the optimal plan, the suggestions. And the optimal plan is basically what do we need to produce and how much, when to produce where, what is the transportation plan to take products in situations where we have products that are only produced in specific locations and where we have demands in some other locations. We need to decide how to bring them to the customer. We need to decide about the procurement, as I said, in case in which we need to model the suppliers, etc. And when we speak about optimization is really guided by objectives, by metrics. And this is where KPIs come into play. Here I'm showing you a few examples of KPIs, but we may have other KPIs, but the main KPIs will be the demand satisfaction, the service level, so tardiness. We may have KPIs about operational efficiency, etc. So this whole optimization model that takes input data and generate optimal plan can be used to do different functions, like planning, of course, but it also can be used to do what-if analysis, so create different scenarios, do what-if comparison. It can be used to do KPI comparison in case where we adjust the plan manually. And also in situations when we need to do replanning, we can do some local optimization to replan, to respond to disruptions or to respond to deviations from the planned operations. So now let's go straight to the demo. So this is the application. So the application works with the concept of scenario. So the scenario is an entity that contains all the data, the input data and the output data. And the idea here is to be able to run different scenarios, compare them, change input data, see the impact on output. So here I will start with this demo scenario. And the first dashboard I want to show you is the demand dashboard. So this dashboard will allow us to have an overview of the demand. So we can check the demands by month. So here I'm seeing the demand for the next 12 months for each individual product. Of course, I can do some filtering. For example, I can show only the seasonal products. So here we can see that these products are changing and are varying over time. I can, for example, check one specific product. If I see, for example, swimwear, we can see that most of the demand is really around the summer months. We can see the same information by customer. So this is where we can highlight the most important customers typically, but also we can check this information by product to see the most critical products for us. Here in this table, we can check the detailed demand, and we can also adjust if needed. So demand will have information about the customer, what is the SKU, what is the quantity that we need for this customer, the due date, and the priority. So once we review the demands, once we agree on the demand, we can run the planning. So to do the planning, we use this button. So this takes 2-3 seconds to run. Okay, so now the planning is done, and to review the planning, we go to the global dashboard, and this will allow us to check the main KPIs of the solution. So here we can see the revenue, the lost revenue, which are one of the most important KPIs, but we can also check more operational KPIs like the storage cost, transportation cost, the processing cost, the setup cost, and this is what will allow us to evaluate the quality of the plan. So in this situation, it's an incapacitated plan, so we do not consider the machine's capacity, and that's why actually we are fulfilling all demands and we have zero lost revenue. And by the way, we can also check the revenue breakdown by region, so we can check what are the most important regions that are bringing most of our revenue. So now, what would be important and interesting here is to have an idea about the plan, but while considering the production capacity. So to do that, I duplicate the scenario. I call it capacitated. Okay, so here I created a copy of my scenario. Now I need to go to the simulation dashboard and go to the production capacity. So now I will enable the capacity constraints for all my locations. And I run my planning. So this again takes 1 or 2 seconds to run. Yes. So now I have my solution. So what could be interesting here is to compare, right? So compare the first scenario with the second one where we consider the capacity constraint. And of course, as you can see now, I have more lost revenue. Of course, I have less processing costs because I'm producing less. And in order to dig a bit deeper into why and which products we are losing, we can check the demand fulfillment here. So you can see that in months of June and July, I am having some lost revenue. And in a way, this is natural because this is where we have actually most of our demand in June and July and August. So I can check that, but I can also check in more details my demand satisfaction. So if I go to the demand satisfaction here, I can check the I can check the demands that are not satisfied. So demands with lost quantities greater than 0. So here I'm filtering all my demands that I'm not fulfilling. So you can see that I have demands from China, from France, UK, Italy, and USA. So to have an overview of how much I'm losing from each individual region, you can check the lost revenue by region. So here you can see that China is really presenting a big part of the lost revenue that we're having. And to confirm the issue, we can check the capacity of China. If I go to China here, we can see that really I'm reaching 100% usage and really reaching a bottleneck of my capacity here. And that's why I'm not fulfilling the demand. So what can be interesting to do here is why not produce before and store my product to anticipate the demand. And this is where optimization is really powerful because it allows to do that. So let's duplicate this scenario. And now let's allow inventory. Let's inventory. So here I will simulate a situation where I have like infinite inventory capacity just to simplify our demo. To do that, I just put any negative number here. Consider that this is an infinite capacity. And now I run my plan. Okay, so now I have my new solution. You can see that now I have 0 lost revenue. So now I'm really able to fulfill all my demand. How? By inventory buildup. So by really making some products in advance and anticipating the future increase in demand and really trying to reduce the cost of inventory, of course, as much as possible. But what is most important, what is more important than inventory cost is demand satisfaction cost. So we need to do the to do some inventory buildup right before the peak of our demand. So if we compare here to the second scenario with capacity, so of course we can see that we eliminated completely the lost revenue, but most importantly we have storage cost. Of course we have more processing cost, but especially we have more storage cost. And what can be interesting at the strategic level is, for example, to decide what is it more costly to invest in capacity or to invest in warehouse space. So, for example, we can create another scenario, a fourth one, in which I simulate an increase in capacity. So let's say I simulate an increase in China by 10%. And we can compare the different costs between these two scenarios and see, is it more interesting to invest in capacity or to invest in inventory space? So to do that, it's very easy. We go to the capacity adjustment, and here I can adjust China capacity by adding 10% here. So the capacity is adjusted right away. And now I need to plan again to see what is the best way or the optimal way to use my capacity and see the impact on my KPIs. Okay. So I can see that, okay, I have 0 lost revenue, same thing, but is there an impact on other KPIs? So if I compare with the previous scenario, you can see that now I'm able to reduce by 90% the storage cost. So this really can show and can highlight this balance between capacity investment and inventory space investment. And this is one of the decisions that can be made at the strategic or tactical level. So of course, we can also go into more details and check the quality of check exactly the production plan by going to the production dashboard that shows by region, what should we produce, what are we producing exactly on each month. And we can go into more details about the production orders by checking tables in the by checking the information in the table here. And when it comes to simulation, we can simulate other situations where, for example, we simulate that we're losing one customer. For example, here I can simulate this situation where I'm losing customer. Simulation dashboard. And here, let's say, for example, I lose the customer 5. It's one scenario to do that. I go to customer 5 and I put almost 100%. So here I'm losing my customer. Of course, if I plan here, I will see a reduction in my revenue. I will see a reduction in my processing cost, and maybe also a reduction in inventory cost. But in any ways, we can really see the impact by checking the KPIs. So of course, it's a reduction in revenue. I'm improving my storage cost because I don't need to produce this, I don't need to store it, etc. So when it comes to simulations, we can also configure the length of the horizon, of course, but we can also go into more advanced configuration, like configuring the different optimization objectives, the priorities of the optimization objectives. So I hope this demo was interesting for you. If you have any questions, don't hesitate to reach out to us at our website, decisionbrain.com. Thank you.